In this problem, they would like for me to solve for the grams of H2O gas that are required to produce a certain amount of oxygen. So I'm solving for grams of our reactant. And what did they tell me? What was the given? The given is all of this, 4.2 liters of oxygen. And so I'm going to write that down underneath of the oxygen in our balance equation. That oxygen is at a temperature of 294 Kelvin and a pressure of 1.32 atm. And so my given is oxygen and I want water. So this is a stoichiometry problem because I have one chemical and I'm asked to solve for another chemical and they're related through this balance equation and the mole ratio. And the heart of stoichiometry is turning our given into moles of that given. Then we can use the coefficients and get the moles of the want and then eventually turn it into whatever unit they want me to solve for. Well, since oxygen, they gave me the volume, 4.2 liters, they gave me the temperature, 294 Kelvin, and they gave me the pressure of that oxygen gas of 1.32 atm. How do I use this information to solve for moles of the oxygen? How many moles of oxygen? This is a gas. They gave me volume, temperature, and pressure. I'm looking for moles. We're going to use Pivnert, the ideal gas law, to solve for the moles of oxygen. So that is step number 1. Let's solve for the moles of oxygen using the ideal gas law. All right, so I have plugged in all my values into the ideal gas law, and now I'm just going to solve for N. Okay, I just realized that I had a small mistake here. I didn't have quite the right value here. I had the rounded value for the R. So I just want to point out that I did change my setup here to 0.08206. Anyhow, I solve for N and I get this many moles of O2. And again, I'm going to continue to use the value in my calculator, but it is okay to kind of truncate your answers here on paper. All right, so I have moles of my given. The next step would be to calculate the moles of the want. All right, here in step 2, we are calculating the moles of H2O gas, or water vapor. Again, we're going to take our moles of our given oxygen, and we are going to use the mole ratio from the balance equation, aka we are doing stoichiometry. We are taking those 2 moles of water and setting it equal to 1 mole of oxygen because those are the coefficients from the balance equation. All right, so step 3, I'm just going to continue though with our dimensional analysis. Step 3 will be to convert our moles of our want into the desired unit for the problem. This question wants us to solve for grams of H2O, so we'll just go one more step here. Convert our moles of H2O into grams of H2O, and we're going to get 8.3 grams of H2O as our final answer. Okay, so for a recap of this problem, step 1, we calculate the moles of the given, that's the oxygen gas. Since our given was a gas and they gave me all the variables of our ideal gas law except for the moles, I'm going to use the ideal gas law as the way that I calculate the moles of our given for this problem. Then we take those moles of the oxygen gas and we use stoichiometry to calculate the moles of the want. And then step 3 of the problem would be to then convert your moles of the want into whatever unit the question wants you to solve for. In this case, it is grams of H2O. And then finally, we round for our significant figures here, and it is 2 sig figs. So our final answer is going to be this 8.3 grams of water.